Welcome back for the next composite problem. So if you move over to the composite section with me and scroll over to your, I have to scroll. If you turn the page over to these two shapes that are identical, we're going to first find the area and then the perimeter. And the perimeter is going to be by far the most difficult of these two, the more difficult of these two. So I am going to zoom in a little bit so that we can see what's happening a little better. And I'm going to put my parsing line in. Now, if you needed a line of symmetry, you would go this way to divide it into mirror images. But we want to always look for shapes. So I'm going to separate the triangle away from its base, the square at the bottom. So here's a triangle, and it looks like it's an equilateral, but I would not assume that. We have to use not what we think it is, but what we can prove it is. And then at the bottom I have this square that is 18 by 18. So the square is usually not going to give me a problem. They're pretty basic little shapes. I like squares. And to get area, we need the two formulas. The square is just length times width, or that's the one I'm using. There is the other one, and then for your triangle, you want to use 1/2 the base times the height. So those are the two recipes that we need for this problem. And the square, again, is an 18 by 18. That is the easier of the two. So let's go ahead and get that. I believe it's 324, but let me double check. Yes. So that is 324 square feet for our square. The blue part alone is 324. Okay, to get the triangle, we need to know base and we need to know height. Well, usually height's the one that I have to work for, but in this case, it's giving me the height. It's 27, and if it helps you to go ahead and draw it in there, that's fine. But it's the base that I need to work with just a little bit, because I need to go from this edge to this edge, and that's 9 and 9, but I also have this blue section in here that is part of that square that's 18 feet. So to get your base, you have to do a little bit of work. We have to say 9 plus 18 plus 9. And when you add those up, you'll have that total distance across the bottom of that triangle, and that's 36 feet. Okay, then you will need to multiply these through. So 0.5 times 36 times 27 is 486 square feet. But remember, we want the composite area, not just the individual areas. So we have to put those together. 324 plus 486. And that'll give you 810 square feet for the composite area. And I know that's not easy, but the perimeter one is going to give us a little bit more work. So there's the area. Okay, down here at the bottom, we have the same shape. We just want to find the perimeter. So again, I'm going to put in the parsing line, and we can color this one in. I think that's a good thing. If you have some highlighters or colored pencils, you can do this with me. Just helps you to visualize what you're dealing with a little bit better. And you don't have to color. You won't be able to color on the exam unless you just shade with your pencil, but for teaching purposes, I always like to use color. So So remember, we're dealing with two separate and distinct shapes. But also with perimeter, we are concerned about the outside only. So I can tell you, and I'm actually going to white mine out. I know this would not be easy for you to do, so don't worry about it. But I'm going to take out this part because this is a height. This is the inside height of this thing, and we don't care about inside. We're dealing with perimeter here. So we need to know this side and this side and this side. Let's mark these off with points. That may help. So starting at the top and coming down this way, there is one side. Here is two sides, three sides, four sides, 5, 6, and then back to the beginning is 7. So we have a 7-sided figure, but we only have 4 numbers. So we're going to have to come up with those other numbers. Okay, there's one of them that's pretty straightforward, and that's this one right here. We know that that missing side is 18 because it's part of that square. But these two are going to mean some work. So let's zoom in on these two and see what we know. And I'm going to try just to pull it in here. Now remember, I whited it out, but we do know the height of this thing. Let's go ahead and put it in the middle where it belongs. And that was 27. I need to know this one. I need to know the hypotenuse of this right triangle. So hopefully you realize, if you're looking at this, that this is a right triangle. Right there, this half of this triangle is a right triangle. And I'm going to come over here and draw it just like this so I can work with it this way. So let's pull out just that half, and that'll help us a little bit. And we know that this is 27 because that's the height. We need to find hypotenuse. That's the mystery. Is what's the length? No wonder my pen is so dark. I forgot that I changed it. I was thinking, why in the world is that so dark? So we need to find the hypotenuse. There we go. But we know that this is 27 feet. And we actually know this bottom one if we think about it. Because remember, we found this whole base from edge to edge. We knew that the base was how much? Well, it's up there, it is 36 feet. So we know that this is half of that 36. If the base is 36 feet, if I go ahead and divide that 36 by 2, cut the base in half, I would get 18, and that's going to be this dimension right there. And that's half of our whole base. And now we can use Pythagoras rule, the as the crow flies rule, of a squared plus b squared equals c squared. And I like to use a as the tall one. It does not matter. You can do it either way, as long as you leave c as the hypotenuse. That's very important. Okay, 27 times itself is 729. And 18 times itself, is that 324, I believe? Yes. And then we're going to add those two together to get c squared. So 1053 is c squared. And take the square root of both sides, and this will not be even. This problem was probably not meant for perimeter. So I'm going to say it's about 32. It rounds to about 32 feet. So now we can go back to our yellow section and fill in this about 32 feet on both sides. And now we are ready to do our perimeter. And let me go through and highlight the numbers that I'll need. I need this 18. There's side 2, side 3, side 4, side 5, 6, and 7. So those values will give me my perimeter. 18 plus 18 plus 9 plus 32 approximately plus 32 approximately plus 9 plus another 18. 1, 2, 3, 4, 5, 6, 7. Let me show you a simplified version of this that you sometimes will see. If you look at this string of numbers, I see 3 of them that are 18s. I see 2 of them that are 9s. And I see 2 of them that are approximately 32. So sometimes they'll simplify it and write it that way, but it works either way. You can just add up the whole thing, or you can type it in as this simplified form. However you like to do it is fine, or you can do it both ways just to check yourself. But either way, I'm thinking it's 136. And let me check again just to be sure, because I do make mistakes. Yes. Okay. One thing that I do need to go back and fix is this right here. The perimeter is not 136. It's approximately 136 because we had to round to get those 32s. So just to be very precise, it is about 132 feet. Not easy problems. These are some of the most difficult we've had to do. Okay, I'll see you in the next video for one more two-dimensional composite.